Yeah, hello, welcome. Thank you. I haven't done anything yet, but it's really a pity that we only have such a small room. So, who am I? I live in Göttingen in Germany. I co-founded Zenit like in 1996. First Samba patches from 1994, porting Samba at that time to a Next workstation. And I'm a very early Samba team member. Jeremy says third, fourth, whatever. I don't know. Yeah, possibly. I mostly work on Samba infrastructure, TDB, event file server. I'm one of the authors of the clustered file server that is being utilized in large storage environments. And I have my hands in winbind, which I'm going to talk about here. The Active Directory domain controller, that's the colleague Stefan Metzmacher. He has initially implemented the multi-master replication protocol just by looking at what's going on the wire before we had documentation. In fact, it was his bachelor thesis, I believe, to implement the DRS UAPI protocol. And so he's our expert on Active Directory.
Famous 8,000 hours of work.
Well, yeah, whatever. So, what is this talk is being a bit of a high-level overview of what Active Directory and Samba authentication is. And in particular, I try to get you a picture of who trusts whom, who can talk to whom, who can answer what questions and so on, what tasks are involved to get a Samba user authenticated, and why the different aspects are important and so on. Quick overview. What is Active Directory really? It's Microsoft's central user database since like Windows 2000. Before that, Microsoft had a Windows NT4, which was a flat user database, just a list of users. You had a GUI limit of like 40,000 users in a single database, and even at that, it was very clumsy to use. But yeah, it worked. They moved that to an LDAP database, and they also put in Kerberos as an authentication protocol, as a standard authentication protocol. This LDAP database is multi-master replicated, and as always, you have problems with multi-master replication. For all the conflicts that can arise, they have strategies to mitigate that based on whatever kind of conflict, what attribute this is on. For example, I believe on passwords, it's last writer wins. If you remove a directory somewhere, an OU somewhere, and move something into that OU on another domain controller, for each of these cases, Active Directory has strategies to work around that, and it's well understood these days. The LDAP is highly specific, and this is what I was talking about. Well, this was my comment in the last talk. They have very custom extensions, and that are partly to accommodate huge directories that are not really covered well by some aspects of the LDAP standard. They have a lot of internal magic in their implementation to make sure the internal schema requirements and all non-schema requirements are actually met and always valid. Also, Active Directory, as used to be, is a challenge response based authentication server. And even in the world of Kerberos, this is still very important for reasons I will point out. Of course, it's also a DNS, and they went to standards for doing domain controller lookup. And yeah, one aspect that is in practice relevant is that when you go to customers, you will very often find very complex multi-domain setups that have all sorts of trust in between. I guess our friends can tell stories about this. People do all sorts of multi-domain setups, and Active Directory is made to cope with that, better or worse. But if you go to a university, it's very common to only have one single realm. But if you go to Active Directory, I mean, dozens of domains or hundreds of domains is not really uncommon. So what is Samba? Started in the 90s. as a compatible file server to DEC Pathworks. It used to be based on Solaris at that time. That has long gone. It's an implementation of many Microsoft protocols. It started out as server message block, which is a pure file server protocol with some printing extensions. Based on that, Microsoft has added many other protocols. In particular, they have taken the distributed computing environments RPC implementation and extended that big ways. Samba is a print server using DCRPC. It's a RPC server for user database services, and this is essentially what is the NT4 compatible domain controller. Then, as I said, we have Kerberos servers, we have a DNS server, we have an LDAP server, and so on. DNS, of course, is again not invented here, but yeah, bind is also kind of a moving target when you want to hook into it, and there's so many DNS servers. And in the end, for the requirements that we have, DNS is not really a complicated protocol to implement. We have been an NT4 compatible domain controller, what we call nowadays classic domain controller. It still works for ages. With Samba 4 we became an Active Directory domain controller, and what we have been for a very long time is an Active Directory domain member, because what you see is normally companies, customers have their Active Directory and they want to just have Samba or Linux workstations join that Active Directory and be normal participants in that authentication realm. What is authentication? What is authorization? We have to distinguish between those two. Authentication is mainly to identify users. Did the user type in the password correctly? Is the user really the one who he or she claims to be? The second question is authorization. What is the user allowed to do? And how does Active Directory specify what a user is allowed to do? It's mainly by listing groups a user is member of. And this is what we call the access token. And we have to distinguish those two questions. And I will talk about both aspects in the next few slides. Let's talk about general authentication mechanisms. Telnet FTP, well, everybody knows it. Not spending much time here. The main advantage is, which distinguishes it from all the other ones, is you don't need plain text passwords on disk of the server. In particular, challenge response and Kerberos, they require plain text password or the equivalent of those on the service disks, on the authentication service disks. So the authentication server can always impersonate. A Unix machine with the etc shadow can't impersonate the user against other machines. And this is where SSH fits in. They authenticate the server by public key and then pass on the password in plain text, and it doesn't matter. It's not bad anymore. So we have essentially plain text on net, but encrypted on disk. Then we have plain text on net, encrypted or sealed by public key. And then we have all sorts of channel response schemes. And Active Directory uses these two. Kerberos, I mean, I always have to think very hard to make sure that Kerberos is actually safe. But my take from it is really it's a complicated version of channel response. Okay. NTLM versus Kerberos. Who has heard the NTLM acronym? So it's the NT LAN Manager Challenge Response Authentication Protocol flavor. Challenge Response Authentication Protocol really abbreviates to CRAP. On the other hand, recent versions are not really as bad as they used to be. I mean, the initial versions coming from OS2, for example, they were really, really crap, even at that time. But they are actually quite good these days. If you go to latest NTLM v2 with all the added nonces and all the exchanges, they are usable. Of course, you will always find enterprises where they are banned, but everybody still, or 99% of the customers I meet still have that enabled, and they are not regularly attacked by flaws in that. There's a downside to this NTLM thing, and we will talk about the different roles in a minute. For every single authentication event, anybody trying to authenticate needs to ask a domain controller. And that's pretty high load on the domain controller, depending on the kind of authentication you have. Just guess HTTP, for example. Very short requests, and you have to cache something somewhere. Then we have Kerberos. It's the standard authentication protocol. The main distinguishing factor is we have lifetimes of tickets. Meaning somebody can authenticate and get some signed binary blob token that verifies to somebody else, hey, Volker Lendeke has authenticated correctly. That's the main thing of Kerberos. And this means greatly reduced load on the domain controller due to this caching. The main downside is it's extremely picky. So I don't even want to start. I mean, the time synchronization is basically solved, but that's number one. The other one that I frequently meet is you have to contact the server under its name. You can't just contact an IP address. It doesn't work because you don't find the service principal in the KDC database. And if your DNS is broken, if you have C names, if you have local etc hosts, Kerberos just doesn't work. And so this is one of the takeaways that you should really take out of this talk here. NTLM as a crap fallback must always be available. Otherwise, you will have very, very unhappy users eventually.
This also breaks migrations, clean migrations, because companies do not expect that they actually fall them back to NTLM. And they have broken Kerberos because of that. And they think that everything works, but in fact, it isn't.
Experience from the field, Alexander's comment was, many companies don't know that they are still using NTLM, and they have broken Kerberos for some reason. I mean, it can all be fixed, but it can be broken. It is often, very often, it's broken. Yeah, and every single breakage needs to be analyzed. So, roles in authentication. We have a user. Hey, I want to access this box. I know a password. I have a certificate. I have something. Then I have my workstation or a server. This server usually doesn't have a user database local. That's the whole point of having authentication servers somewhere. And then we have a domain controller. In KDC, in Kerberos speak, it's a key distribution center. We have domain controller. And those guys are the point of trust. They have all the users. They are the gatekeepers for all access control decisions. And the point I want to make here, which is very, very important, is these guys here need to trust these guys. Because the KDC can tell the workstations or servers that Volker Lendeke is root or administrator or whatever. So there must be some level of trust between those two, and this trust must be cryptographically assured. So how is it done? Each workstation on each server has a shared secret with the DC. And so when a workstation wants to authenticate Volker Lendeke, the DC must prove it knows the secret. So the domain, not only Volker Lendeke authenticates itself against the workstation, but also the domain controller authenticates itself against the workstation, so that the workstation can eventually be sure, yes, Volker Lendeke was authenticated by the right domain controller. Kerberos speak, it's principal, service principal, and key tab, where they have to agree. So, same in Active Directory. Enter Samba winbind. It's a daemon that we wrote a while ago. I think, was it Tim Potter who initially wrote it? And it's a daemon that essentially takes care of all this stuff that I was talking about. It connects to domain controllers, and it can be surprisingly complex to find the right domain controller. For example, you have Active Directory sites, and you need to be site aware. So if I'm sitting in Europe, I'm not talking to the domain controller in Kazakhstan. Because, I mean, I have satellite links in Africa, whatever, and I don't want all my authentication go to Africa and back. And this is what Microsoft has the concept of sites for. They can tell me, hey, I have 25 domain controllers. The 3 of those are local to you. That's all done with server records and DNS. Then what it does, it connects to one of these domain controllers and establishes an encrypted channel, authenticated and encrypted channel to that domain controller. And much of this is really, really nasty. And you don't want to implement that yourself. And this is all being taken care of by winbind. What it does also is it changes its machine password regularly, which can be surprisingly difficult given that you have multiple domain controllers. You change your password against one, that domain controller dies. Or you change it against the domain controller has accepted that change, but then your local write to your disk fails. And yeah, there are some aspects to take care of. And this is all that winbind takes care of. What winbind provides is an extremely simple interface. And quoting Simo, it's just crap and too simple. But it just has some fixed size requests and it works. Okay, usernames can't be longer than 256 bytes. That's one limitation here, but who cares? It's really extremely simple, and we provide a library that wraps all the ugliness for anybody who wants to use it. But it just works, and yeah, it's one of the hidden secrets that nobody has to take care of. Nobody has to bother. Samba provides PAM and NSS modules, so it can authenticate users. It can give you the illusion of Active Directory showing up in etc password and etc group. And one very important aspect is it tries to simulate where it can what Windows does and do nothing else but what Windows does, because that's all we can rely on. Anything we do that Windows doesn't do in normal operations can break. We're not there yet, but we're getting there. Okay. Authentication done by NTLM. Winbind can do NTLM. Winbind can also verify Kerberos tickets and so on. And this is done. What's authorization? What is the user allowed to do? Eventually, that's permissions from access control lists in the file system in normal Unix operations. How do we evaluate ACLs? That's all based on user IDs and group IDs, small 32-bit numbers. How do we get there? First, we need to answer the question, what's a user ID and what group? What's a user's UID and what groups is he or she member of? Who knows? It's the domain controllers. The question here is, when do they tell us? And Active Directory domain controllers, and this is one of the big misunderstandings, only ever tell us, and they calculate the group memberships only when a successful authentication has been done. So if a user presents his password either via Kerberos or via NTLM, that is the only moment when we can reasonably figure out what groups the user is in. Anything else is prone to break. Okay. Winbind and trusted domains. winbind performing several tasks. We do the authentication, as I said. We do the password checks. Winbind has authenticated the user, and as I said in the last slide, we have gotten the token, the list of groups. The problem is, in what format did we get these groups? Windows has a completely different notion of a user ID. Essentially, it's a 128-bit user ID. It's called security identifier. It's this. Maybe some of you have seen this one, S1532/454, S1521/ and then many numbers. But at the bottom of it, it's 128-bit UIDs. Unix can't deal with that. I would love to make Unix deal with 128-bit UIDs, but it would solve us this topic here. And I'm not going to talk about this topic because it would be like a 2-hour talk in itself. There are so many ways that winbind is able to map these 128-bit UIDs it gets from the Active Directory into the 32-bit UID space that is given to it by Linux. So we can ask Active Directory for database lookups. We can do it on our own. We can, whatever, have script-based solutions and so on. If you're implementing Samba in an Active Directory, this is a hot topic that definitely needs clarifying with customers. And this is different for every single customer. Okay, winbind also provides NSS information. Important question. I said winbind connects to a domain controller, establishes a trust and an encrypted channel. Who can we establish this encrypted channel to? And as said in one of the first slides, it's extremely common to have very, very, very many domains, cross-realm trusts. And winbind can only ever talk to its own realm/domain. So if user A from domain A, user A from domain whatever, 1, comes to winbind, and winbind is member of domain B, I would have a whiteboard, would need a whiteboard now. So winbind is member of domain A, user from domain B comes to winbind, hey, please authenticate me. Winbind depends on the domain controllers to talk to each other, to take over the inter-domain trust stuff. Winbind can only talk to its own domain because that's the only domain we have a workstation password for, we have a shared secret for. We can establish trust. So right now, this is the part where we're not there yet. I said winbind wants to do only what Microsoft Windows plans do. Right now, by default, we have code to list all trusted domains and to also contact other domain controllers. Although we really can't, or we can't really, depending on your point of view. This worked fine in NT4 times when the trust scenarios were a lot simpler. Active Directory trust, you don't, another whatever, 10 slides talk, what kind of trust you can have. And these are a lot more complex and yeah, the failure scenarios are much more diverse. And so winbind in 4.8 will have code to just drop this. The problem is you have this code in winbind, it does all this stuff, and because the situations out there are so different, you don't know what's exactly going to break when you just disable this. And so what we do is we optionally say, okay, we don't do all this, okay, let's talk to the trusted domains and so on. We just disable this optionally and ask people, hey, please disable this and report failures, because we can't really reasonably test all the scenarios that we have to live in. Because, I mean, we can't set up 500 domains in whatever trust scenarios. Okay. From this slide, essentially, this bullet point here is I told you much of this. 2 points here. Active Directory groups are hell complex. In particular, something that Unix doesn't know, really. I mean, for LDAP, for pure LDAP, we have data models for this. But in plain Unix etc password etc group, there is no group nesting. Active Directory has all sorts of group nesting, and Samba, as a pure client, has no way to follow all this group nesting itself. I mean, in theory, the database offers it. The data is there. 2 points. First, it's hell complex code. Second, we might not have the access permissions by Active Directory to see all this information. And that's why it's so important that we have to rely on domain controllers to calculate group memberships with all its nesting at successful login time. We have no way to calculate it on our own. Essentially, it comes down to, if you log into a Unix box that is part of Active Directory using winbind, you are root on that box. The piece that doesn't work is ID blank username as root. This doesn't work. If you SSH into that box as a successful login, as that user, typing in ID without username, hey, I want to find my groups, that works. What does not work is ID blank username typed in as root, because I have not done a successful authentication against the domain controller. One of the big misunderstandings that I face really in customer scenarios, not daily but monthly at least.
You could try to do an LDAP search for the token group.
Yes, go here. Go. Token group is not reliable. Once you enter trust, you are not able to contact the trusted domain controller, and so on. I mean, it's a mess.
You don't even know that you're deprived of
Yeah.
access to that.
Yeah. I mean, there's one way we're working on this. There is a service that Microsoft offers. It's service for yourself. Andreas already mentioned that. That is supposed to do something similar. That will solve it. Okay. Then another slide that is a bit out of topic here. Winbind NSS info. So winbind as a client can provide the name service switch info. Essentially, it can fake etc password etc group. How does it do that? Windows doesn't know about the concept of a login shell. Windows doesn't know about the concept of a home directory, the same semantics that Unix expected. And we have some same changes here. Active Directory can hold all this information in LDAP attributes. We can read that. One particular change is, I think, when did that go in? In 4.7, 4.6 or 4.7 that went in. If you look at the Active Directory users and groups tool, there's 2 primary groups. First in the Windows group tab, and then in the SFU schema extension tab. And before the change, I think it was 4.6, before this change, we always went in and used the Windows primary group and expected to have some external ID mapping for this Windows primary group, which was, in most of the cases, it's just domain users. And a lot of customers, for whatever reason, refuse to map Windows domain users to a Unix group, because they have applied this separate primary group for a user in the Active Directory SFU tab. And this is something that we recently, I have it there, 4.6. Samba only looked at the Windows group, and we changed this now so that you can be more flexible and say, okay, if you have these SFU extensions, you don't want to map the Unix domain, the Windows primary group, just go here and say Unix primary group equals yes, and then you can have a per user primary group out of the SFU tab. Okay. That's it. Questions?
Should we turn the lights on?
Lights on. Thanks. Yeah.
So if I recall correctly, a customer set up a Samba environment as clients, 80 clients,
Yeah.
and it could easily do get and possibly get and group on those machines.
Yeah.
So, but if you say that winbind only gets that information on successful login, how did that work?
That's different. So the question was, how does get and password, get and group work? That does work, although you don't want it, and we disable it by default. Get and password will enumerate all users, and in large Active Directories, this can be slow. You don't want this. We disable this by default. It's listing users can be done via LDAP, or it can't. It can. Active Directory can prohibit this, so it's not reliable. In many environments it works, but it's not reliable. The other thing that doesn't work is getting the list of groups a user is member of. That piece is utterly unreliable. Just listing users, listing groups is one thing, but getting the reliable, up-to-date information about which groups is a user member of, and this is the only one a file server is interested in, that piece doesn't work.
What is there? What is the scenario where this is dynamic? I mean, it's a quite, I have my admin set a day and I, do all the changes required by my office, business, company, whatever. And then there's that for the next 2 months. So where's the...
Imagine Siemens. People come and go every single hour.
Yeah, okay.
People change groups every single hour.
DevOps.
Yeah.
All the DevOps, new machines coming out.
Okay.
Every company.
So that's highly dynamic, and you have to ask that information at login time. And as I said, please don't ever type in winfo-u to list users. This can take down your Active Directory because it's just too slow. More questions?
Thank you.
Okay. Thank you.